What if I told you infinity isn't just what you think, but something your brain literally can't handle? Now imagine you're walking down a corridor. You reach the end, and it stretches farther, again and again. No matter how long you walk, it never stops. That uneasy feeling, that's your mind breaking. That's infinity. Now it gets weirder. Infinity plus 1 is still infinity. Infinity minus infinity could be 0 or something else entirely. Because infinity isn't a number you calculate with. It's a direction, something that never ends. But here's where everything changes. Some infinities are bigger than others. Take 1, 2, 3, forever. Now take every number between 0 and 1, infinite decimals. That second infinity? It's bigger, not metaphorically. Mathematically, you can never match them up, ever. An infinity, larger than infinity. Now look up. The universe itself might go on forever. No edge, no boundary, just endless space. And if that's true, infinity isn't just an idea, it's where you already are. Let's go back to basics for a second. Because to truly feel how strange infinity is, you need to feel how it breaks the simplest things. Addition. You learned it in second grade. 2 plus 2 is 4. Always. Reliable. Safe. Now try infinity plus infinity. Still infinity. Okay, fine. Now try infinity divided by 2. Still infinity. Infinity divided by 1,000,000,000? Infinity. This is not rounding. This is not approximation. Infinity divided by any finite number, no matter how gigantic, gives you infinity back. The number you divided by simply disappears. Like it was never there, like it meant nothing. That should terrify you a little, because it means infinity is not playing by the rules of the universe you grew up in. Now I want to introduce you to a man who stared directly into infinity, and it nearly destroyed him. His name was Georg Cantor, a 19th century mathematician who decided, against all advice, against all sanity, to treat infinity like something you could study, measure, compare. His colleagues thought he had lost his mind. One of the most respected mathematicians of the era called his work a disease. The church thought he was challenging God. Cantor himself collapsed into depression multiple times, in and out of sanatoriums for the rest of his life. But he was right. And what he discovered is one of the most beautiful and disturbing things in all of human knowledge. He proved that some infinities are strictly larger than others. Here is how. Imagine a hotel with infinite rooms. Every single room is occupied. No vacancies. Now a new guest arrives. Normally, full means full. But the hotel manager, who understands infinity, simply moves the guest in room 1 to room 2, the guest in room 2 to room 3, room 3 to room 4. Every guest moves one room forward, and suddenly, room 1 is empty, the hotel was full. A new guest arrived, and there is now a vacancy. Nothing was destroyed. Nobody left. The hotel just made room. This is called Hilbert's Hotel. And it gets worse. What if an infinite number of new guests arrived? An infinite bus with infinite passengers? The manager moves every current guest from room N to room 2N. Room 1 goes to room 2. Room 2 goes to room 4. Room 3 to room 6. Suddenly, every odd-numbered room, an infinite number of rooms, is empty, and the infinite bus fits, a full infinite hotel, absorbing an infinite crowd. And still, somehow, infinite rooms are empty. This is not a trick. This is how infinity actually works. Now let's step into physics. Because infinity does not stay politely inside textbooks. It shows up in the real universe. And when it does, physicists panic. When Einstein's equations of general relativity are applied to the center of a black hole, the math spits out infinity, infinite density, infinite curvature of space-time. Physicists have a word for this. They call it a singularity. And what singularity really means, underneath the technical language, is this: our equations broke. We reached a place where the numbers stopped making sense, where infinity appeared, where a real answer should be. It is a confession that we do not know, that our best theory of reality, the most tested, the most precise theory in human history, reaches a wall. And on the other side of the wall, it just writes infinity and gives up. This happens inside every black hole. This happened at the moment of the Big Bang. The universe began at a singularity, which means the universe began at a place where our math collapses. We do not know what was there. We do not know what happened. Infinity swallowed the answer. And now the largest question: is the universe itself infinite? Not just big, not just bigger than we can see, but actually, truly, without end, infinite. Current evidence suggests the universe is flat, not curved into a sphere that closes back on itself, just flat. And a flat universe, according to our best cosmological models, is an infinite universe. And in the end, Cantor, near the end of his life, exhausted, institutionalized, questioned by nearly everyone, wrote that the concept of infinity had been communicated to him. Not discovered, communicated. He believed he had not invented it. He believed he had been shown it. Whether that was the belief of a genius or a man broken by staring too long into the abyss, we cannot say. But consider this: infinity existed before anyone thought of it, before humans, before language, before mathematics. It was already there, built into the structure of numbers, of space, of time. We did not create it. We just finally looked directly at it, and the looking changed us. Infinity is not a number. It is not a place you can reach. It is the proof that the universe is under no obligation to be the size your brain expects. And somewhere, in the gap between 0 and 1, in the empty rooms of a hotel that should be full, in the center of a star that collapsed into silence, it is waiting, not for you to understand it, just for you to finally admit that you cannot.